We're asked to verify this identity, and like any identity, we're going to start with one side and work towards the other. I'm probably going to start on the right side, but before I do that, I want to do kind of some stuff to both. Remember, there are times when we want to look for a third non-thing. And I know that this is a half angle, but I know that my half angles are just sine, cosine, and tangent. So I'm going to rewrite this as 1 over tangent squared x over 2 equals 1 plus cosine x squared over sine squared x, which means that I can flip both of these. This is tangent squared x over 2 equals sine squared x over 1 plus cosine squared. Okay, now why is that helpful? Well, because now I have something I can actually look to solve. And then I'm going to take the square root of both sides, and I get tangent half equals plus or minus the square root of sine squared theta over 1 point cosine squared theta. Okay, so now my goal is there are 3 versions of the tangent half angle version, and I've got them up here. My goal is to end up with my right side looking like one of these. So that's my goal here. And I already have the plus or minus radical, so I'm kind of thinking that that's going to be a good choice. So that's going to be kind of my aim, at least my starting goal. And if I get sidetracked along the way, I'll change it as I go. So first, this I can rewrite using a Pythagorean identity. This becomes 1 minus cosine squared x. And then I have under here 1 plus cosine squared. Okay. Then what I'm going to do next is I'm going to factor this right here. This is a perfect square binomial. So this is 1 minus cosine x, 1 plus cosine x. Now this bottom, if I write it out, is 1 plus cosine x times 1 plus cosine x, which means those cancel. And I'm left with plus or minus the square root of 1 minus cosine x over 1 plus cosine x. And if I come back and look, I can see that right there equals this identity. So that means what I have here, I just went right by it, equals tangent x over 2, which proves my identity. So a little bit of factoring skills thrown in here, a little bit of rearranging. So we did kind of do the method of where we're looking for a separate third. Once I looked at cotangent, I knew cotangent wasn't one of my options for something that already had a, theorem of its own. Then I wanted to rewrite it so I could use it.